we can start our class today. Actually, we are going to finish this chapter today, and this chapter will be included in the mid-semester exam. I think we have our exam on 12th, isn't it?
Yes, sir.
I think we have our exam on 12th. Do you have any exam at 11?
No, sir.
No. Can we have a mock test at 11? I mean, just for 5 or 10 minutes, maybe we will have, and then we will just see whether we can give a sample exam or not. Can we do that?
Yes, sir, we can do that.
Yes, sir. Yes,
All
sir.
the sections together.
So all the sections together, maybe we can make the time, say for example, that depends on you, in which time you want to do.
আসসালামু আলাইকুম
ওয়ালাইকুম আসসালাম।
স্যার আমাদের মিড সেমিস্টার এক্সাম আছে 10 তারিখ এবং 11 তারিখ, সরি 10 তারিখ এন্ড 12 তারিখ। সো
12 তারিখ আমারটাই।
জি স্যার, সো ওইটার প্রিপারেশন তো নিতে হবে স্যার। 11 তারিখ কি?
আরে 11 তারিখ তুমি, আই ডোন্ট নো হোয়াট ইজ দ্য প্রবলেম। 10 তারিখ আর 12 তারিখ আছে, 11 তারিখ দিলে সমস্যাটা কি? তুমি তো 11 তারিখ আমার সাবজেক্টের প্রিপারেশন নিবা।
স্যার I was saying that because sir টানা এক্সাম দেওয়াটা is pretty much very much stressing sir.
ইরফান, ওটা 5 মিনিটের মক টেস্ট।
It's not an exam. It's not an exam. It's not an exam. It's a.
So is it obligatory?
I think it is not obligatory, but if you face any problem in the original exam, then I will not accept.
Okay sir.
Because that mock test actually is to be familiarized for the system. Say for example, I will in the Google Classroom, I will give a link, and from the link you will attend the class, attend the exam, and then submit the PDF file. So I want to see for myself as well as you should see as well, because in the exam day, if you say that I am not able to submit it now, or some problem is there, then I will not allow. Okay, so in the mock test day, I think on the 11th, just give me 10 minutes. Okay.
Yes, sir, you are right.
Because I think everyone should know how to upload, or how to send, or how to use the Google Classroom, or whatever the system is. I think so the CRs, please talk with the other CR, and I want you to decide on which time actually you want to give the exam on 11th.
Okay, sir.
Okay. So
Sir,
today
it
is
will be a written exam, right?
just write something. It will be written exam definitely. On 12th it will be a written exam. On 11th also, say just write one line and scan it and upload it. Okay, so I want to see that everyone can upload it or not, just to see this one. Okay, and it will be a written exam. So the class monitors, please talk with other class monitors, and give me a time on 11th, because on 11th actually I will go to IUT, so it is better for me if we can do it after the Maghrib. So we will just take 10 minutes. All right.
Yes, sir.
Okay, I think it will be good. All right, so let's start today's class. So the thing is, this slide actually we have already seen the Gaussian random variable, and the for different kind of variance value or standard deviation value, we are having either steeper or flatter kind of picture or kind of distribution. Okay, now let's see how these are going. Okay. So the definition we are talking about is standard normal random variable. This is very important. Remember one thing, I told you already that Gaussian random variable is something like any kind of mean and any kind of standard deviation, or not delta, maybe we'll use the rho. So we have this standard deviation and we have this mean value for a particular Gaussian distribution. But if we have the mean value equals to 0 and this standard deviation equals to 1, then that Gaussian distribution can be called standard normal Gaussian distribution or a standard normal random variable. Okay, so the standard normal random variable Z is the Gaussian 0, 1. 0, 1 means the 0 means the mean and 1 means the standard deviation or the variance as well. So this is the definition of a standard normal random variable. Why do we need standard normal random variable? Because if we have this standard normal random variable, there is a chart. We will see the chart. On that chart, all these values, say this is a Gaussian distribution with 0 mean and standard deviation equals to 1, and for every value of x, this like a -2, -1, -0.5, or this 0, or this x equal to 1, 2, 3. For different values, what are the tail probability? That is calculated and placed in a table. Okay, so for example, x equal to 3. This value is for x equal to 3. When I will say that what is the tail probability, or what is actually in there, there are actually two chart. One is this area given, another one is this area given. What is that? Just a minute. Okay, so the thing is, I was there at this x equal to 3. Okay, now the idea is there is a chart for different value of x, say -1, -2, -1, 0, 1, 2, 3, like these values, and for every value there are some CDF value. In one chart it is CDF value, and another chart it is the tail probability, like this area. What is the CDF? If this is the x value, then the CDF is the area of this green one. Do you agree?
Yes, sir.
Okay. If x equal to 2, like this one, x equal to 2, what is the CDF value? That CDF value will be like this one, isn't it?
Yes, sir.
Up to this one. So there is a chart for every value of x and its corresponding CDF. So the thing is, we don't need to integrate up to from -infinity to x fx dx like this, because this integration result is given here. All right, so the idea is, if somehow we can convert a general Gaussian distribution into a standard normal Gaussian distribution, then I can directly take the value from the chart and find the CDF at any point of that particular Gaussian distribution. That seems, or that looks a bit complicated. Let's see how it works. So for example, the standard normal CDF already we told you, I told you that standard normal CDF means CDF of standard normal Gaussian distribution, and standard normal Gaussian distribution is 0 mean, 1 variance, and in the equation, look at that, they have put mu value equal to 0 and rho value equal to, sigma value equals to 1, and after doing that they have got this one, and they are making it chi z. This is called the CDF from the standard normal distribution, and this chi z is given in the table. Okay, so this, after giving the chi z, look at this one. This one actually is a conversion. This one is a conversion from a general CDF of a mu sigma random variable Gaussian distribution to a standard normal Gaussian distribution. This phi is actually some kind of standard normal Gaussian distribution. What they are telling, that look at that, this fx x, let us divide those two Gaussian distribution. One is a Gaussian mu sigma, another one is a Gaussian 0, 1. There are two Gaussian distribution. That Gaussian distribution is called standard normal distribution. Okay, that one is a standard normal distribution. And look at this one. This Gaussian distribution is actually the Z distribution, and that one is a F distribution. Okay, so this Z distribution, when I'm talking about this CDF, this Gaussian distribution is actually fxx, and that is a phi. So CDF is told in Gaussian distribution mu sigma, it is fxx. Okay, so when I'm talking about CDF, it is actually from -infinity to x, that Gaussian distribution PDF, where we are talking about mu and sigma is there. But here it is also the similar kind of -infinity to x, fxx, but here the mu value is 0, sigma value is 1. Okay, now the thing is, there is a conversion formula from fx to this chi. A conversion formula is there. We can convert this fx to chi. How? Look at this one. This is the conversion formula. That is fxx equals to chi of x minus mu divided by sigma. So if I am having this mu equals to, say for example, 1 and sigma equals to 1. Okay, now if the x value equals to 2, okay, if x value equals to 2 in this fx, then actually in chi this becomes a 2 minus 1 divided by 1 equals to chi of 1. So this fx, where the x value equals to 2, is similar to phi of 1. Do you understand?
Yes, sir.
Okay, so this fx is a mu mean sigma variance Gaussian distribution, but the psi is a zero mean unit variance Gaussian distribution, and we can convert any x value into corresponding x of phi, and then we use that chart and find the value of psi, which will be equal to this fx value. Okay, this will be more clear when we will solve a problem. Okay, there is one thing shown, the probability of x b equals to phi of b minus. We know that, isn't it? Look at that. This is what? Fx b minus fx a. We know that. And this one is a x value in fx system. Now when I'm talking about phi system, then definitely this b has to be converted into something, and that conversion is b minus mu divided by sigma. Similarly, that one will be what? A minus mu divided by sigma. That's what actually here is it's written. So any Gaussian distribution can be converted into standard normal Gaussian distribution by using this formula. Is it clear?
Yes, sir.
Okay, let's go to solve one. Before going to solve the problem, look at this chart. This is what actually I was talking about. This is a standard normal CDF. Look at that, standard normal CDF. Okay, which is the high y or whatever is x or y or whatever it is, or z, no problem. So look at this value. This is the z value. Okay, look at this. So this is from z equal to 0 to z equal to 3. Why the minus value is not given? You will be able to understand. Look at that. In a z or standard normal distribution, what is the value of mu? In a standard normal distribution, what is the value of mu?
Sir, 0.
0. Very good. What is the value of sigma?
1.
1. Very good. So look at one thing. If I say that the value of z equals to 0, actually this is a z variable system. So at z equal to 0, what should be the CDF? Can you tell me what should be the CDF? Because this is the z value equals to 0. This is 1, 2, 3, minus 1, minus 2, minus 3. So around z, the Gaussian distribution is there.
Sir, half.
Half. Very good. Why half? Look at that. This is a symmetrical Gaussian distribution. That means half portion is in the left side, half portion is in the right side. We know that the whole probability is how much?
1.
1. So if the whole probability is 1, definitely the half probability will be half. So as z equal to 0 is the middle point of this Gaussian distribution, so actually the Gaussian distribution is distributed around this 0, z equal to 0. So when I'm talking about, I want to find out psi z. Psi z is what? This is the CDF at point z, isn't it? So when I'm talking about psi 0, that actually is meaning CDF at point 0. And what is the CDF at point 0? That CDF at point 0 definitely is this area, isn't it?
Yes, sir.
And this area is half of the whole area. So that's why that value is equal to 0.5. Look at the table. Look at the table. At z equal to 0, that phi z equal to 0.5. The more you are approaching in the right side, that means the more value of z is increasing, you are finding that your psi z is increasing and increasing, because the number of area, or the area will increase more and more and more. At z equal to 0.01, 0.02, 0.03, the more you are going in the right side, the more the area will be included in the CDF. Do you understand? Look at
Yes,
that.
sir.
Look at that 2.99. There is a value at 2.99. So this is 2.99, and you're finding that almost 99.86% data actually is in the left side, or you can say the CDF is almost 1, 0.9986, something like that. Okay, so this one actually is the CDF for the standard normal distribution. So if we can know that x equal to 3, and we are converting that x equal to 3 into z, and that z equal to 2.01, if it is 2.01, how to find out 2.01? Look at this. This is the 2.01. This is the 2.01. Can you see it?
Yes, sir.
So 2.01 is 0.97778. So we will say that the CDF at z equals to 2.01 will be equals to 0.97778. And this is the same as fx, or x value equals to 3. That will be also this 0.97778. Do you understand?
Yes, sir.
So this is how, and this is why we have to convert. Yes. Any question? So
Sir, in this
yes,
chart, we can see the Z value is from 0 to 2.99. Is
right.
this the range for Z, for all Z?
Actually, not this is the range for z. Actually, after 3 value, there is a generalized formula. I mean, where we don't need to integrate. We have a almost equal sign formula for that one. So if the z value is more than 3, then we will use that formula, and directly we can calculate it from the equation. That's why it is given up to z equal to 2.99. In some chart, there are some chart where the z value is up to 5. So the thing is, if the z value is more than 3, then actually we will use that particular formula to solve the integration. Okay.
Okay, sir. Thank you.
Okay. So let's go to the next slide. So let's go to the next slide. Okay. What is the time? Can you give me 5 minutes?
Yes, sir.
So please, I want a 5-minute break. All right, just 5 minutes. Inshallah, I will be back within 5 minutes. Thank you. Okay, I mean, so are you here? Are you here?
Yes, sir.
Okay. So we're talking about this conversion. Okay, the conversion from this general Gaussian distribution into a standard normal distribution. Okay. Now look at this example. Suppose your score on a test is x equal to 46. A sample value of the Gaussian 6110. What does it mean?
Mu equals 61 and what is it?
Sigma,
Sigma equals 10.
right. So the 6110 is mu 61 sigma 10. So this is a Gaussian random variable. This is given. Now your score is x equal to 46. Now express your test score as a sample value of the standard normal random variable z. Okay. So we have to just change the x to z, nothing else. Okay, we don't actually need to find the CDF, but we just need to convert x into z. So we know actually that this z value, actually how to find out, it is x minus mu divided by sigma. The z value actually is x minus mu divided by sigma, isn't it? So if we do that, what the value becomes? Let's see. This z equals to x minus mu divided by sigma, we can understand. And then this value becomes minus 1.5. In the chart, actually the minus 1.5 was not there. Okay, so it is actually what? It is actually, if I want to find out, then look at this Gaussian distribution. It's a zero mean Gaussian distribution. And the value we have found, it is 1.5 with a minus sign. So actually it is something like this one. So the z value equals to minus 1.5. Now if this is actually the answer of the example, but if I want to find out that the CDF at z, then definitely that will be this one, isn't it? And
Yes, sir.
actually in the chart we have values for 0, 1, 2, 3 like this, or 0.01, 0.02 like this. In the right side, there is no value for the negative values. Now, how to find out things like that? How to find out a negative value CDF? Let's see. Look at this one. This is one theorem that they are telling, that phi of minus z is equals to 1 minus phi of z. What does it mean?
It means that for minus 1.5, we have to get the phi z for 1.5 and then minus it for.
Right. We can check. We can check because all these are symmetric. So remember one thing, if 1.5, this is minus 1.5 and this is a plus 1.5. Remember one thing, as it is a symmetric thing, so definitely this value or this area is the same as this area, isn't it?
Yes, sir.
So if somehow we can find this area, actually we can say that this is this area. Okay, now phi of minus 1.5 is that particular area, and phi of 1.5 is which area? That is
The area on
actually
the right.
not right, the area on the left. This is psi means what?
Oh, okay,
CDF.
sir. Yes, sir.
CDF at 1.5. So actually the area is something like this one. This one is the area. This one is the area. Now I need to find out that particular area because this area is the same as this area, is the same as this area, isn't it? So to find out this particular area, is the same as finding out this particular area, and is the same as the whole area is 1 minus this green dot area. Do you understand?
Yes, sir.
So this area is actually that particular thing. So that area equals to what? So I will say that phi of minus 1.5, that will be equals to 1, that means a full area, minus this area, and 1 minus phi of 1.5. Is it okay to all?
Yes, sir.
All right, so I think we can understand how this is working. So this theorem is that one. Definitely we can understand that how it works. Okay, and the thing is, now they are telling that we had this Gaussian distribution previously. What is probability of x less than equal to 46? What that mean? X less than equals to 46, isn't it the same as z less than equals to minus 1.5?
Yes, sir.
Isn't it? So, and that one actually is what? That we have already found out. That will be equals to same as, this is actually equals to phi of minus 1.5, and that is equals to 1 minus phi of 1.5. Is it clear?
Yes, sir.
Okay. So the thing is, if I see what actually is this one, look at that. P of n, this means fx of n, that we know, and that means that psi of minus 1.5, and that means 1 minus psi of 1.5. And if you go to the chart, see the phi 1.5. Let's check it. Let's check it. What is the chart value? 1.5 minus 1.5. Or so this is the chart, and let's see the 1.5. 1.5 is in the top. Let's remove this one. So this is 0.9332. Can you see this one?
Yes, sir.
So for 1.5, the value is 0.9332. So if I go to the next slide again. Okay, so we can see this one. So that is the same as 0.933. They haven't written the 2, so no problem. So we can write 1 minus this one, and we can find out that 0.067. So phi of minus 1.5 is actually equals to 0.067. Very small probability, because it is in the tail side, so a small probability. Is there any question regarding this problem? Any question? Okay, so if there is no question, then we can go to the next slide. Maybe we have more topics here. Yes. So they are telling that 0.067 means 6.7% of the population test takers are actually lowest than 1.5 standard deviation. You can guess that one, no problem. Not much important. Maybe we can go to the next slide. Yes. Example 3.17. So another example is given where the mu value is 61, rho value is 10, the same thing, and they're finding out what is probability of 51 to 71. So we can understand, we will find the CDF at 71, then CDF at 51, and then subtract, isn't it?
Yes, sir.
And we know how to convert CDF at 71 into Z, then CDF of 51 into Z, and we can find it from the chart, and we can put the value, and we can just subtract, and we can find the result. All right, so let's see how they are doing. So at first they are finding out the Z values. So Z values for 51 and 71 is 1 and minus 1. Okay, so this one value is for 71, and then minus one value is for 51. Okay, and phi of 1 can be found from the table, and phi of minus 1, we know that formula. Phi of minus 1 equals to 1 minus phi of 1. So we have put this one, and then actually it becomes 2 phi of 1 minus 1. And the phi of 1, if I take it from the chart, then we can easily calculate, isn't it? Can you
Yes, sir.
understand? Very easy. Very easy. So we can do it. And then standard normal complementary CDF. This is the complementary CDF. Remember one thing. Complementary CDF actually is something like the tail probability. This is called the tail probability. What is tail probability? In the Gaussian distribution, we were finding the CDF. CDF at X means the left area. And when I'm talking about the complementary CDF, it means the other area. The other area. At point X, if I want to find out the complementary CDF, then actually we have to find out the area in the right side. What is that? X to infinity, and then probability distribution, integration. The same thing that they're doing. So that actually is 1 minus phi z. When if it is a z, if I'm telling that this is a z value, then when I'm talking about phi z, it is actually the left side area, the CDF. When I'm talking about complementary CDF, it means 1 minus phi z, phi z. That is this area. Is it clear?
Yes, sir.
Okay. Then let's go to the quiz number 3.5. Look at this one, quiz number 3.5. And we have been given X is the Gaussian random variable. Actually, it is a standard normal distribution, definitely. And Y is the Gaussian 0 to random variable. This is another random variable, which is not a standard normal distribution. Sketch the PDF of fxy, fyy. We can easily do that because here Gaussian distribution 0 to, the standard deviation is more. So that one should be more flat, isn't it? That one is this one. And that one should be some kind of this one. Can you understand?
Yes, sir.
Both are 0 mean, but standard deviation is different. So the more standard deviation means more flat. We know that. Then sketch the PDF. Already we have done that. What is probability of from -1 to 1? Okay, so we have this fx. This fx is very important because this fx is a standard normal distribution already. So when I'm talking about probability from -1 or -1 to 1, then actually we are doing what? We are actually dealing with a z. Same thing, because this is the standard normal distribution. So this is what? Phi 1 minus phi minus 1. Very simple, isn't it?
Yes, sir.
Okay. What about this one? Number 3. We have to convert this one into standard normal distribution first, and then we will use those points, because this y from -1 to 1, these values should be converted, isn't it?
Yes,
Because
sir.
because this y value equals to what? This y value equals to or the z value equals to this y minus mu divided by sigma. We know that. And if the y value is a -1, then it is 0, and then standard deviation is 2. So actually it is -half. So it becomes z equals to -0.5. And similarly, we can convert the 1 as well. Okay, we can do it, isn't it?
Yes, sir. Sir,
Yes.
can we find out the z of 1 from the chart and then 1 minus 2 into phi of z.
Oh, sorry, for which one? For this one?
Sir, yes, sir.
This one is, we cannot use these values directly because this is one Gaussian distribution, which is not a standard normal distribution. Its value is 0, 2. Look at this one. Look at this value.
Oh, okay, sir. I get it now.
Its value is 0, 2. It's not 0, 1. So if it is 0, 2, then we have to convert these values, this -1 and this 1 value. So we cannot put z1 minus z2. I mean, shy of 1 minus shy of -1. We cannot do that. We have to convert
Okay,
this
sir.
-1 and 1 first, and then we can find out. It seems that it is from -half to +half. I think, yes. I think it is -half minus half, something like that. Okay. Then number 4. What is the number 4? Look at this one. This number 4 is telling probability of x more than 3.5. Remember one thing here. What is x? X is a Gaussian distribution like this, and this is a standard normal distribution. So here x more than 3.5 means actually z more than 3.5, isn't it?
Yes, sir.
So when I'm talking about z more than 3.5, actually we have to find out this area, and this area we know it will be 1 minus shy of 3.5.
3.5.
Okay, and this value can be done by using that equation that I told you already, and that equation can be used here and we can find it. All right. Similarly, this y more than 3.5, at first we need to convert this 3.5 into z, because y is not a standard normal distribution. You understand?
Yes,
X
sir.
is fine because x is already a Gaussian standard normal distribution, but y is not a standard normal distribution, so y has to be converted into z first. So this 3.5, what is the value in z? We need to find
E
out
minus
first.
0/2.
Right. So 3.5 minus 0 divided by 2, something like 0. Not 0. 1.75 maybe. So this is the value for this case, and then we need to find out z more than or equal to 1.75, and we can find it by phi of 1.75 like this, 1 minus, because it is more than. We need to find out the more than case. We need to use it 1 minus phi of 1.75. Can you understand?
Yes, sir.
Okay. So let's see the result. I'm not sure what actually we have done. So we have done this one, no problem. This one we can easily do it because it is a standard normal distribution. And then the y value we have to calculate and we have to find out. Look at that one. So this 1 minus 0 divided by this sigma, minus 1 minus 0 divided by sigma, and we have found out the values. Then this x is a Gaussian distribution. This can be found out directly. They actually have found out by q, but actually we can do it by 1 minus phi as well, no problem. So because we will give only the chart for phi, so you have to use that phi equation, no problem. And then y is a Gaussian distribution. We have converted to 1.75 and then 1 minus phi is 1.75, and we have done it like that one. Is there any question? Remember one thing, for x more than 3.5, we are telling about one equation. That equation I think is available in your book, I think. If not, then try to find out in the net, because I think it is in another book. Maybe I can supply you the equation if you don't get from the net or the book. Okay.
Okay, sir.
Okay. So I think there's no problem regarding this one. And then we're talking about this probability models of derived random variable. For the derived random variable, we know that the derived random variable is there, that is this fx, because x, I mean y is a function of x, so definitely x equals to y by a. So if the CDF is like this, I mean if y is a function of ax, then y has a CDF and PDF will be like this one. So if x y is a function of x, so from x PDF or y PDF, I mean x PDF or x CDF, we can find out y PDF and y CDF. Just in the PDF value of x, put the value of x equal to y divided by a, then it will be enough. Okay, so we have an example for that. We have a PDF like this. We have a PDF like this. Now they are telling to find out the PDF of y. For the PDF of y, so they are trying to find out the sketch of PDF for a value like this one. At first, we need to find out the PDF of y, and we can actually do it by just putting it like this one, 1 by a. Say for example, a equals to half, then we will say that half. Let's say for example, we are talking about a equal to half, so this will be 1 by half means 2, and then fx means what? Twice x. Put the value of y by a in twice x, so that will be what? That will be 2 into y by half or y by a. So let's put it a for general case. Okay, so that will be actually 1 by a into 2 into y by a. Is it okay?
Yes, sir.
Okay, so the thing is that will be 1 by a square twice y. So this is the PDF of y, isn't it? And if I put the value of a equals to half, then PDF will be one thing. If a equals to 1, PDF will be another thing. And then if a equals to 2, PDF will be another thing. So let's see those PDFs. What are the PDFs? Look at this one. This is the PDF of y. 2y divided by a square already we have found out, and by putting value of a, we are finding the different probability sketch. Okay, we can do that because by putting y value equals to 1 2 3 4 5 or 0.1 0.2 0.3, we can actually plot it. So it's not a big deal. Is there any question here? No question. So let's go to the next slide. So there are some theorem, that is if x is a uniform random variable, where I told you already that if y is a function of x or y is a derived random variable, then if x is a uniform random variable, y will also be uniform random variable. If x is a exponential random variable, y will also be an exponential random variable with these values. And these values will be just changed. BC will be AB, AC, lambda will be lambda by A. This R lung will be R lung and with values n lambda and n lambda by A. Gaussian will be Gaussian with mu sigma equals to A mu A sigma. Okay, nothing more than that. This is actually easy things, and we can go to this conditional PDF. Actually, we know all these things. That's why I'm going a bit fast, because this conditional PDFs we know several times in the previous chapter, isn't it? We already have seen these things, and then this summation things we have. This is the total probability theorem, and we have seen this in the previous chapter. Similarly, the EX can be found out, x into fx summation like this, isn't it? Are these the same as the previous chapter?
Yes, sir.
Yes. So this is the same as the previous chapter, so we don't need to go in detail. This is the last problem in our chapter, so let's finish it and then wrap it up. Wrap it up means finish it up. So the thing is, the probability density function of this random variable y is said is given that it is a uniform random variable. You can understand. So from 0 to 10, it is some kind of it's a kind of thing like this one. Okay, so this is the FYY. Now they're telling find the following probability of y less than equal to 6. It's a very easy one, because the fy is given and probability of y less than equal to 6. So from 0 to 6, if I integrate, that area will be very easy, isn't it? Y from 0 to 6, then this probability, this one is 1 by 10, and then it is 6. So I think it is 6 by 10, isn't it?
Yes, sir.
Very easy. The conditional PDF probability of y, condition y less than equal to 6. We know regarding this kind of probability to how to solve it, isn't it? Conditional probability, this one equals to probability of y divided by probability of y divided less than 6, and that one is 6 by 10. So this probability of y divided by 6 by 10, and we can easily find out, isn't it? Okay, so this is already given, this y less than equal to 6, we know that, and then just divide this probability by this probability, then we will get this one divided by this 6 by 10, we'll get this one. Number 3 is what? Probability of y more than 10, more than 8. If this is 8, more than 8 means what? That one will be 2 by 10. Sorry, yes, 2 by 10, isn't it?
Yes, sir.
From 8 to 10, it is 2, and the height is 1 by 10. So multiply, we'll get 2 by 10. Similarly, we can do the conditional probability, no problem. And we have this PDF, how to find the expected value. It's very easy. Y into fy, conditional y less than equal to 6, the summation, isn't it? Isn't it? So let's
Yes, sir.
see how they are working. They are finding the results. First one is 0.6, 6 by 10, very easy. Second one is, already we have seen that 6 by 10. This one is 1 by 10. So 1 by 10, sorry. So how to do that? This 1 by 10 by 6 by 10. So it will be 1 by 10 into 10 by 6. That will be equal to 1 by 6. That's given. Okay. Then the third one, it is 2 by 10, isn't it? And then the fourth one, similarly, we will just divide 1 by 10 divided by 2 by 10. So it is becoming half. And similarly, if I go to the expected value, just normal fy summation. This fy already we have found out in the third and fourth question. So if I do that, then we can get the integration and we can find out the solution. And the second and the sixth one is the similar case. In this case, also the same thing will happen. Previously it was from 0 to 6, now it will be from 8 to 10. Is there any question regarding this problem? Okay, so I think we have okay, and one exercise problem is actually added. In the exercise problem, we have these random variables. CDF is given. How to find the EXM variance of X? If it is CDF is given, we have to find the PDF first, isn't it? So from the CDF, we'll find the PDF. How to find PDF from CDF? Differentiate, and we can find out the PDF. If I find the PDF, EX is what? X into FX summation or integration. And then finding variance, we have to find the expected value of X square first. And then expected value of X square minus expected value of x whole square. That will give us the variance. All right, look at this one. This is the fx, and we are differentiating. Look at that. We are actually differentiating. We are differentiating, and we are finding out this half. This x by 2 differentiation will give us half, and then this differentiation of 1 will give us, what is going on? What is going on? Stop sharing. Can you see it now?
Yes, sir.
So we can have this PDF value, and then this EX is what? X into FX integration. Integration is what? Because this PDF range is from 0 to 2. So definitely this range will be from 0 to 2. And this fx equals to half. So x into half means x by 2. Integration dx, 0 to 2. And that will give us maybe 1, because we know that this is half into x square by 2, integration from 0 to 2 equals to what? 1 by 4. Then x square means 2 square minus 0. That means 1 by 4 into 4. That will be equals to 1. That is 1. Is it okay?
Yes, sir.
All right. It seems that only a single person is attending the class. Is there any other people who are understanding?
Yes, sir.
Okay, please respond, because I am thinking that I am only teaching a particular person. Okay, so is there any question regarding this one?
No, sir.
No. So we have this ex. Definitely we have to find out the ex square as well. Ex square, similar kind of thing. And then variance equal to ex square minus ex whole square. And then this is the result of this thing. So remember one thing, you have to go through the different kinds of example, different kinds of chapter questions, and also you have to get the concept, because there can be some questions different from the previous year questions. So as this is a online exam, so there can be some exams, there can be some questions which will be different from your previous year questions and your book questions, and there can be different sets as well. Okay, there can be different sets as well. So be careful, try not to see others' papers. And I think this is the end of the chapter. If you have any question, you can ask.
Sir, how many questions will be there in the mid?
4 questions. From 4, I will take 3. There will be 1.5 hour exam, and just like a mid exam, and I will try to give some kind of problem, so that the cheating will be minimized, and you try to not to see the others, try not to do any unfair means. Okay.
Okay, sir.
Yes, sir.
Sir, you mean everyone will have their own question?
Everyone will have their own question, definitely, but they may not all be unique.
Oh,
There can be some overlapping.
okay.
Also I will try to make that unique, because maybe I can use those values unique for every student. I can do that because in the 4th year, in the last semester, I have given them one question which actually depends on
Sir?
yes.
Okay, you explain something.
Now the thing is, we will try to give a mock test before that.
Okay, sir.
So that will give you an idea about what kind of question or what type of difference between
Mhm.
different people can be.
Okay, sir.
Okay. Say for example, just I'm trying to share one whiteboard kind of thing. Let's what the thing I was talking about is, say the thing, say in the last year what I have done, say your last 3 digits of your roll number, that is 112.
Okay.
Okay, and that 112 is converted into 8-digit binary. If if there is 4-digit or 5-digit, previous one will be complemented by 1. So everyone has a unique 8-digit number. Okay, now I can use different bits and make a value for a particular question, and then I tell you to use that particular value for that particular problem. Do you understand?
Come again, sir.
You have a roll number. Say for example, what is your student ID?
245.
245. Okay, fine. 245. There is a site. I will give the address of the site. If you just put the 245, that will give you a corresponding binary value.
Okay.
So the binary value is 10110.
Okay.
Okay. So this binary value is not an 8-digit value. So to make it 8-digit value, we have to insert 31 in previously. Okay. So now you are getting a 8-digit number for 245 student ID.
Okay.
For different people, this 8-digit ID will be different. Do you understand?
Yes, sir.
And if I say that this is the C1, C2, C3 up to C8, and in the problem I'm telling that the value of say for example x equals to um, uh, C6, C5. What is those C6, C5? 1, 2, 3, 4, 5, 6.
Yeah, 1 1.
1, 1. So your value is equal to 1, 1 in binary. So that will be equals to 3.
Okay.
So you will work with 3. Your value for x equal to 3. The whole problem solution, you will do it by using x equal to 3.
Okay.
So for everyone, the value will be different. You understand? Even if the
Yes.
problem is same, maybe,
Mm.
but the value will be different.
Okay.
So you cannot just see your friend and copy his
Copy it.
script.
Yeah. Mm.
So in this way, actually, I will make that whole question unique for everyone. All right.
Okay. Okay, sir.
So is there any other question?
No, sir.
Okay.
How many questions will there be from chapter 3?
I will not explicitly tell, but one question definitely will be there from one chapter,
Each chapter, one question.
at least, because there are 3 chapters and you will have 4 questions.
Okay.
Okay,
Okay.
sir.
Answer all.
I'm thinking.
So
thinking.
the time is 1.5 hours.
1.5 hours.
4 question, answer 3. That will be better.
So I'm thinking whether I will give 4 and answer 3, or I will give only 3 questions and answer 3. And that
Okay,
can
sir.
also be done.
Okay.
Okay. So thank you very much.
Thank you. As some attendance.
All are present.
Yeah,
Be
last
happy.
class, at the end of the class, I got disconnected and I joined. They said the class is finished. I was
Oh,
not.
okay. Just please remind me in the next class, because I need to see the attendance sheet. I don't have it now here. So all the students are present today. Regarding the previous class, if you have any problem, then you remind me in the next class, or maybe in the class after meet.
I think today is the last class. Oh,
Today is the last class before meet.
Okay.
Before meet. Okay.
Okay.
Is there any other questions?
But you will do mock quiz with us.
Mock
for us
quiz
to
with
know how
all of you. With all of you. Right. With all of you. So
Okay.
class monitor, please arrange a time on 11. Okay. Is there any other questions? Okay, so thank you very much. Thank you very much.
Assalamu alaikum, sir.
Wa alaikum salam.
Assalamu alaikum, sir.
Wa alaikum salam.